optimization, we're looking for maximum or minimum values. To review the one above that, do you remember we cut the corners out of a piece of paper and folded it up to make a box? We found maximum volume, okay? This one, we want to consider all lines that pass through the origin. Okay, what's that point? Yeah, 0, 0, and this equation. Now, as an ordered pair, that would be x, comma, x squared minus x plus 16. If you wanted a point on this equation, you would pick an x number to plug in, and then whatever you get out of this is your y value. Does that make sense? Okay. Well, I mean, does it? You pick an x to plug in, and then whatever you get from plugging it into this is your output value. All right, at what x value does minimum slope occur? We need an equation for slope. I'm going to use m for slope just because it's what we use for slope most of the time. And you're going to do regular old algebra 1 slope. It's going to be this, so x squared minus x plus 16 minus 0. I'm going to write it. You don't have to. Please stop that. Okay. Over what? Minus 0. Good. I just did that because in case it wasn't the origin, you could see how it would get set up. But since it is the origin, these zeros, we can pretty much ignore those. All right. Now, your maximums and minimums come from critical points. How do you get critical points? Derivative equals 0. Perfect. All right. What rule do we need for this derivative? Perfect. It's going to be the denominator. And then derivative of the numerator would be 2x minus 1. Good. Minus the numerator, derivative of the denominator would just be 1. I wrote it because I'm doing the problem in front of a whole group of people. If you don't want to write it, that's fine. And then it's over x squared. Perfect. I'm going to set this equal to 0. The first thing you would do is multiply over your x squared, but 0 times anything is going to just be 0, so I'm going to sort of ignore that. And then we just need to do a whole bunch of algebra with the numerator. What would you do first here? Yeah. We're going to distribute. What's that? So if you were to multiply the x squared to the other side, 0 times anything is still just going to be 0. That's the nice thing about 0. It sort of absorbs everything, right? So this will be, 2x squared minus x. And then what are we going to do with the second part? Yeah, we're going to distribute the negative. Okay, so basically everything reverses its sign. Minus x squared plus x minus 16. Cool, right? Now what?
Equal to 0.
Yeah, it does equal 0.
Find like terms.
Good. So the only like terms we really have are a minus x and a positive x. So, oh no, actually we do have more like terms.
Yeah.
Well, those cancel, and then this would give us, yeah, just an x squared minus 16 equals 0. There's 2 ways you can, bless you, actually proceed from there. What would you do next? Yeah, so the 2 ways you can do this is difference of squares, bless you, which would give you x plus 4, x minus 4. And so you get plus and minus 4, and that's the correct answers. Or you can add over the 16, but you have to remember that when you square roots, you put plus and minus. Either way, you will get the same answers. Is it okay to get 2 answers? Well, let's see. Well, actually, we're going to need to check that, aren't we? I hadn't thought about that. It says we want the minimum slope. So let's see. Let's make a number line for our derivative here. Our x squared minus 16. If I make a little number line for that, I've got negative 4 and positive 4. Let's actually check that. And we're going to do a good bit with number lines today, so this will be good practice. Can you give me a number that lives on this side of negative 4? All right, so let's plug negative 5 in here and just see if it comes out positive or negative. We don't need to really worry about what the answer is, just whether it's positive or negative. Above or below sea level, if you will. Negative 5 squared. 25 minus 16 is positive. Okay? Give me a number that lives in between. 0 squared is 0. Minus 16 is negative. Yeah, actually, we are going to dismiss one of the answers, aren't we? And then if you pick a number bigger than 4, like 5, This is going to come out positive. Actually, this is perfect. And I didn't even plan this. I mean, actually, I meant for this to happen. Because what we're going to talk about today are your first and second derivative tests, but I can get away with saying this to you guys because you actually learned it last year. This one is going to be the location of a maximum, and this one's going to be the location of a minimum. Why is that? Yeah, positive to negative means up and then down. That's maximum. Negative to positive means down and then up, so that's minimum. So which one's the answer? You have to go back and read the directions. Did we want maximum or minimum? We wanted minimum, and so our answer is actually just x equals 4. Oh my gosh, that could not have gone more perfectly. That's literally the lead-in. Like, that's actually like what I'm teaching today. That turned out perfect. Love it. Okay. Yes. Yeah, did it work? I thought I set it up so that you wouldn't. I apologize. It's working for some people and not others. I've approved it. It's fine. You're good. Okay. As a heads up, just so you know, you will do a little bit of writing today. Okay. I always call this like our English unit or our essay writing unit, but I'm going to drill these justifications into you. And when you get to this on the AP exam, you're just going to nail it because the answers don't change. It's the same thing over and over and over again. Okay. So critical points, we just went over that. That's where the derivative is 0 or undefined. 0 or undefined. Think like an absolute value graph. You can't get a derivative at that point. We'd say not differentiable at that point. But those are the locations of your maximums and minimums, and that's what we just did in our warm-up. When you want to find a maximum or a minimum, like an optimal, like optimization problem, you find your critical points, right? So here's our first derivative test, and I just used the warm-up to do this. That could not have gone more perfect. I wish that I could say I had meant to do that, but it was accidental, but it worked out. All right, f prime changes positive to negative, and this is where, and talking about abbreviations, do not put a plus sign for positive and a minus sign for negative. They will not accept that. You can abbreviate the words positive and negative, but don't put symbols for them. No, don't do that. Abbreviate the word, okay? Go ahead.
It works both ways, like positive to negative or negative to positive.
I'm not there yet. Can you just hold on? Okay. F prime changes positive to negative means that that is the location of what? A relative maximum. Positive to negative, because if you think going up, then going down, increasing and then decreasing, positive to negative, okay? F prime changes negative to positive, that gives you the location of relative minimum. Negative means decreasing, positive means increasing.
I know that it's not relative.
Are you talking about absolute?
What is relative?
Relative means relative to the points around it. So you have a change in the graph from increasing to decreasing or decreasing to increasing. So it's the top of the hill or the bottom of the valley. It just means relative to the points near it. Okay? All right, so what we're doing here, please don't forget what I'm teaching, okay? If your original graph is increasing, your derivative is positive. If your original graph is decreasing, your derivative is negative, and that's how they match up. So increasing positive, decreasing negative. This is going to be slow going at first. That's my pep talk. We're going to slog through this, and I'm going to make you write every single last little thing, and then after that, we'll kind of just do it verbally. But I want you to write everything at least once, right? Kind of small, okay? First thing we need is our derivative. I made the math kind of easy on this because the sentences is what I really want to focus on, so the math is not going to be all that hard. What's our first derivative? How about everybody just do it and we'll just make sure we get the same thing? Equals 0. Beautiful. A lot of times on the free response part of your AP exam, it's a point for linking those together. Or you can even just write this and they'll give you a point. So make sure you write everything, every thought that goes through your head, you want to make sure you write. Calculus is kind of done. Now we're going to do some algebra. What are we going to factor out? So we can do GCF here. 3x, good. That would leave you with x plus 2 This one's going to give you 0, and this one's going to give you -2. Okay, I'm going to make a number line for my derivative. Now, people always get excited. Oh, I found the answers. I found the answers. 0 and -2. On a number line, -2 comes before 0. So just make sure you don't get so excited you found the answers that you put them in, the wrong order. So be careful. So I'm looking at my derivative that I factored here. You don't need to work this out the whole way. You just need to figure out whether it's positive or negative. It's kind of like, I always think of like, the gladiators when they're like, anyway, that's welcome to the inside of my brain. All right, give me a number that lives in this section. -4, okay? 3 times -4, if negative is the point, -4 plus 2 is negative. So a negative times a negative is positive. And that's all you're doing. You don't have to work it out the whole way. You're just figuring out whether it's positive or negative. All right, give me a number in between here. -1. This portion would be negative. This portion would be positive. So negative. And then a number bigger than 0. 1 or 5 million, even if you wanted. That this part would be positive. This part would be positive. So positive.
Wait, do we even really have to formulate? Just learn that they alternate?
So I was going to bring that up, but you did first. If you have a term that is squared, it will not alternate anymore. So if you don't see anything that's squared, as long as you do the first section correctly, yes, it will just alternate and you can go and fill it in. If you have a term, like if this 3x was squared, it would not follow that. Because when you square something, it is always positive and that throws a wrench in it. Okay, but you aren't wrong. If you notice, hey, there's no squareds in here, if you want to just do this first section and then go, yeah, it alternates, it'll work. So you are correct. Yeah.
You can also do it, check to make sure you do your.
Yeah, so, and yes, you're all right. Yes. I would do all of them just to make sure, because if you mess up the first one and then you just alternate it, they're all wrong. So yeah, I think it's a good idea to check. Oh, here comes the sentence. Oh, more questions. Or are you still having another question?
No.
Okay.
When I put in -1, it's giving positive.
3 times -1 would be -3.
Oh, you put it as a derivative?
Derivative, yes, it's a derivative test. Yep. Okay, ready for the sentences? We found the first derivative. Are we writing a sentence about the first derivative? No, of course not. Why on earth would you do that? You're writing a sentence about f of x. I like to think of them as people and make a story out of it because that helps in my head. We're talking about f of x. F prime is like your source. He's the guy that you're citing. When you guys write English essays, I mean, you're on engineering and stuff like that, but you still take English classes, right? Like, do you know when you, all right, do you know when you have to cite something, like quote so-and-so? F prime is the guy you're quoting. With me here? Okay, so your sentences should start f of x is or f of x has, and your because should be because of f prime. He's the guy you're citing, okay? So we're going to say f of x is increasing, and look at your number line. Where do you think, and just use your common sense, -infinity to -2 union 0 to infinity. You're correct, because you're all brilliant. Because, now why did you pick those sentences? Or why did you pick those sections, I meant to say, I'm sorry. Yeah, now, and I was actually hoping you would say this because I want to have this conversation. If you say it will not give you credit. You have to cite the derivative. So we're going to say because f prime is positive there, or on those intervals.
You know what we're talking about.
Now you have an f and an f prime, and when we get to second derivative, you're going to have an f double prime. So there's 3 different things you're going to be juggling. They will not take it. Okay? No pronouns. Now you're going to write the sibling, I call it the sibling sentence. Don't go somewhere else and say the sibling sentence. That's a colism. No one else says that. But you're going to say f of x is decreasing everywhere else for the opposite reason. Decreasing where? Yeah, -2 to 0, because who is your source that you're citing? Who's the guy you're quoting? F prime is negative there. These sentences aren't going to change. This is the answer. On your AP exam, this is the answer. You have the answer ahead of time. The only thing that's gonna change is the numbers in the problem, right? Now we're gonna do the f of x has. F of x has a relative maximum at x equals which one? The -2 or the 0? -2. Perfect, because you're all brilliant. Now you have to write y. F of x has a relative maximum at x equals -2 because who is the guy you're quoting? F prime. Don't say it, right? Because f prime changes from what to what at -2? Yeah, positive to negative there. I'm gonna make you write out one more sentence, and then after this, if you guys have got it, we'll just do it verbally because the sentences aren't gonna change. The same sentences over and over and over, okay? Your sibling sentence, f of x has what? A relative minimum at x equals 0. Oh, and we'll take the at symbol too, you can do that. At x equals 0 because who? F prime changes. I'm totally using up the space for number 2 here. That's fine. I won't make you write the sentences again. Changes from what to what? Negative to positive. There. It's like essay writing. You got through it though. Good job.
We had to do this every single time.
On the AP exam, yeah. It'll be on there. And trust me, you'll love it because these are the answers. Like I'm just gonna drill you to write them and then you'll have now these will just be verbally, okay? Yeah, go ahead.
So can you just say change the sign? Or do we have?
No, because the from what to what is what tells you whether it's the location of a maximum or minimum.
But change the sign.
Yeah, exactly. Like you don't know which one it is.
No shortcuts.
No shortcuts.
Not the shortcut.
I agree with you. It's not really. Oh, there's one that's worse. Just wait. And I was actually at a seminar once where I was like, "Can we shorten it to this?" And they're like, "No. In no uncertain terms are you allowed to shorten this." I was like, "Okay." But you know what? No, I asked. I literally sat there and reviewed, and I was like, "Hey, can you write it this way?" And they're like, "No." And I was like, "You know what? Bet I'll just tell my students that they have to write it this way. I want you to get the right answer on the AP exam, so you know."
We put like negative and then an arrow.
No. Nope. No, I'm glad we're having that conversation because we have that conversation now and then you won't get it wrong in the AP exam. They will not give you credit unless your sentence is perfect. Do it exactly like I'm showing you. All right. I don't disagree with you. All right. For number 2, what is that the graph of? It's, oh, you know what? It's supposed to just be f prime. The F got written weird. It's supposed to just be f prime. Sorry, that wasn't a fair question for me to ask you. It's supposed to be f prime. Are we writing sentences about f prime? No. Why on earth would they ask you questions about the graph that's literally in front of you? This is your source that you're citing. This is like the guy that you're quoting so you can talk about somebody else. Okay? We're going to just do this verbally. F of x is increasing on what interval? Be really careful. This is not the graph of f of x. I want to see if anyone gets it. Increasing where? 0 to 2 is the first one. Yeah, no, let it sink in. If I just keep telling it to you, you won't get it. You got to see it. Union 4 to.
A little less.
No.
Oh, 4 to. Oh no, it's
4 to infinity. Good. And we'll just do this verbally. Because, you see, you guys got it. The less I say, the better.
It's above sea level.
Above sea level, because f prime is positive. I once had someone on a test that may have told you this, right? Because f prime is above sea level. Please don't do that on your AP exam. Okay? Please positive there. All right, now let's do the other one. It would start f of x is decreasing negative infinity to 0, union 2 to 4, because f prime is negative there. Good job. All right. F of x has a relative maximum. Yes. Or on those intervals. But I would say there is a good bit shorter. Because if you don't specify, it's so dumb, but if you don't specify there, you're meaning everywhere. Again, I am the messenger, but I'm telling you what you need to hear to jump through the hoops to get all the points. Okay. All right, so relative maximum at x equals, I see one answer to this. 2. Let's just do this verbally, because f prime changes from positive to negative. Good. Good. See, again, the less I say, the better off you are. So you have to see it yourself. Relative minimum at. Now there's two answers for this. F prime changes from positive to negative there, above to below. So this one is 0 and 4, because f prime does what? Negative to positive there. Now there's one other that we're going to write. There is neither a relative maximum nor a relative minimum at x equals what? 7. Sometimes they make you mention 7 because it's still a critical point, but it does not give you a relative maximum or minimum. And the reason would be because f prime does not do what there? Change sign. Now that you can say changes sign. Does not change sign there. Okay?
So on the AP test, we can't write the abbreviated and stuff down at the bottom. We have to write the same thing.
Right. You need to do it the way that I showed you here. I'm just kind of trying to take it easy on you. Do you want to write all that again? No, you need to write it like this. Yeah. Yeah, you can abbreviate all your things, but you should have a sentence that starts f of x is or f of x has, and then whatever thing you're talking about, and then after the because, you should say something about f prime. He's your source that you're citing.
And we can't just change.
I would put changes. Goes is a little non-mathy. I would put changes.
And we can't say for f prime is positive, f prime is greater than 0.
Yes, you can say f prime is greater than 0. That means the same thing as positive.
Okay, so that's much better.
Yes, those mean the same thing. Did you guys all catch that? Instead of saying f prime is positive, you can say f prime greater than 0. Those mean the same thing. Okay? Excellent question. We'll take
Stop right there, right?
Yeah, I would always put there, because if you don't specify on this interval or on these intervals, then what you're really saying is all the time. Okay? All right, so the next one, instead of a relative maximum and minimum, do you see how it says absolute? And extrema just means both maximums and minimums. It's just the plural of that word. Okay? Now, this is what is called the candidates test. Candidates test. I brought this up 2 classes ago when we were talking about our theorems. Do you remember intermediate value theorem and mean value theorem? And we did extreme value theorem, and I said this is going to be your candidates test. It just means there is a maximum and a minimum. Your candidates are the end points and the critical points. So it starts out the exact same way. We're going to find our derivative and set it equal to 0. And I just found that derivative real quick because I think we're beyond that at this point. You guys have all got that. It's the algebra that's the hard part. So what can you factor out? 6x. Good. That would leave you with 2x squared. Oh, no, sorry. Oh, you can only take out 6. You're right. Sorry, I got ahead of myself. Well, people are talking, and I hear this jabbering in the back of my mind, and it's bothering me. All right, so x squared plus x minus 1. You can essentially ignore that 6. Thank you. There we go. We got to look after each other. You can essentially ignore that 6, and this is why. If you were to divide both sides by 6, what is 0 divided by anything? 0. So you really don't need that anymore. Okay? And again, that's the joy of 0, is it sort of absorbs everything. All right, so this is going to be 2x and 1x, and then 1 and 1. And we need to just figure out our symbols so that we get a positive 1x in the middle. That means I am going to need negative 1, and then this would be positive 2 on the outside. So 2 minus 1 is 1. So what result do you get out of this one? X equals a half, and this one, negative 1. You're going to make yourself a table. Did you do this last year? Candidates test? Okay, this is the first thing that you guys, I can tell you're kind of like, we never did this. Candidates test. It will be on the free response. There is always a candidates test, all right? So who are your candidates? There's 4 numbers that are gonna go over here. -2, and I like to put them in order. It technically doesn't matter, but I need to put them in order. -2, -1, 1/2, perfect, and then 1. So your end points and your critical points. I'm gonna use a calculator to speed this up, okay? Now I put it in the table, but where are we plugging these into? Because it's not the derivative. The original function, okay? So just hold on and I'll type them in right quick, all right? If you put them into the derivative, you're just gonna get 0, the critical points. So that, first of all, that, and secondly, we want the actual output values, okay? So if we plug in, yeah, I guess -2 and 1 would give you something different. All right, -2, that gives you -8. I'm just throwing them into Desmos here. You just all trust me? All right, 5, 1/2 gives you -1.75, and 1 gives you 1. So we're gonna write our sentence. Absolute, actually, you just start with absolute maximum. Absolute maximum is, what's the biggest number we got?
1.
5. Okay, well, we're gonna get to that. Is 5 at x equals -1? Sometimes they ask you for the output value, and sometimes they ask you for the x value. If you write it this way, it doesn't matter how they ask the question, you will get it right every time. Okay, so write it that way every time. And then absolute minimum is, what's the lowest number we got? It's -8 at x equals -2. You do not need a justification for a candidates test. So you don't have to write any more sentences. The chart is your justification. Okay? So the chart is your justification. I'm gonna skip this one because we're just gonna not have time. All right? It's recorded, sweetie. You can always go back and watch it. I'm not gonna have time to really slow down here because I want to make sure we finish this up and you have time to do your classwork, because some people can't finish their classwork outside of class, even though it's only 6 problems. All right, so we've got 3 columns here, F, F prime, and F double prime. We're gonna repeat what we just did on the first page. Where your function is increasing, your derivative is what?
Wait.
Positive, good job. Increasing, positive. Decreasing, negative. Now listen to me. If that's true from here to here, it's also true from there to there. And in theory, as forever, we're not going to do a third derivative test, but I want you to copy that over again. Increasing, positive, decreasing, negative. And we're going to add one other thing into our little table. Let me just ask you, because you should have learned last year. First derivative tells you about increasing and decreasing. What does second derivative tell you about? The shape, which we call what? Begins with a C. Concavity. Good. Positive means concave up. Negative means concave down. That's the way the abbreviation was taught to me. Some people just put CU and CD. You could write out the whole word. I'm good with whatever. They'll take that abbreviation on the exam. Okay? What I would like for you to all do right now is copy this onto your sticky note. I call this the sticky note problems. And everyone gets used to it, and they're like, oh, sticky note problems. You can use your sticky note on absolutely anything until I hand you a test. I want you to keep it by you. Most of my students just put it like inside the cover of their computer. Although you guys don't have computer covers, so that's kind of unfortunate. Copy that onto your sticky note. I call these the sticky note problems. And it's great because all your justifications are right there. And I'm going to be really choosy about which ones we get to. Yeah, I'll be able to do enough in 9 minutes here. I try to end in 15 minutes. All right. Critical point was where your derivative equals 0 or is undefined. Inflection point is where second derivative equals 0. However, there is a subtle difference. Listen. A critical point is a critical point no matter what. For example, on the front page, looking at this one, 7 is still a critical point. Even though there's not a change there, it still counts. Inflection points only count if there is a change. Your second derivative has to change sign. If there's not a change, it doesn't count. I wrote myself a note to bring in my other document camera so this can stop happening. It has a better microphone too, so it'll be better all around. So here's your second derivative test. If you have a critical point and your second derivative is, what does this mean? Positive, that means concave up, and that means that that critical point is the location of a what? Relative minimum, good. If you have a critical point and your second derivative is negative, that means concave down, that means you have the location of relative maximum. And if your second derivative equals 0, there is no conclusion. The test fails, is what we said. If you're thinking of like velocity acceleration, that's like your cruise control. Ah. And you guys are in my class that goes, I love when I say something and you're all like, All right, we're gonna just pick and choose a couple of these because I won't be able to do them all. And some of this is a repeat of first derivative test. All right, a differentiable function, oh, that should just be function, not functions, has the following. F of 3 equals 7. That simply means you have the point 3, 7. That's all that that means. I prefer it as a coordinate point, so that's how I'm going to write it. What does this tell us? The derivative equals 0. Well, it's a critical point. And it also does mean the derivative or the slope is 0. Critical point. Now this says prime or double prime, second derivative is -4. Don't get hung up on the fact that it's -4. What's important is that it's negative. It could be -700 million. Okay, it's just that it's negative. That means concave down. So what is the overall conclusion? You have a critical point. So our relative maximum is 7 at x equals 3. Good job. That would be like a multiple choice question. In fact, I think I stole that question from a multiple choice AP question. I'm going to skip all of this and go down to inflection points. We did all of this on the other page. It's just another example. We don't need to do it all again. All right. Find the inflection points. You can't jump straight to the second derivative. You have to get the first derivative first. Okay. I don't want to move the paper up and down and make you seasick. What is your first derivative? You're looking up at, so 3x squared plus 6x minus 9. Beautiful. And then we're going to pretend we did all the first derivative stuff. We're going to jump straight to the second derivative. That would be perfect. Set it equal to 0. X is going to be -1. It doesn't count unless there's a change. So if I make a little number line for my second derivative, which is this right here, give me a number that lives in this section. -2. And you don't even work out what it is. It's just like gladiator style, like lives or dies, okay? If you plug in -2 to this, it's negative. If you plug in something bigger than -1, like 0, it would be positive. So is there a change? Yes, this is our inflection point. But you have to check that there's a change. Times when there wouldn't be a change is if you get something squared. Be aware of squareds, because if something is squared, it is positive all the time, and you would have pluses the whole way across, and you don't get a change, right? And here's our sentences. F of x is. It's going to start f of x is or f of x has. So f of x is concave up. Where do you think? Look at your number line. And I'm going to just shut this because this button is bouncing off of the windshield. So just where is it going?
-1.
No, that you're fine with that one. Yes, -1 is and then b plus. Now, who is your source that you're studying this at?
Wait, -1.
Oops, right.
You said -1.
Yes, -1 to infinity is where we have positives. Concave up, where your second derivative is positive. So -1 to infinity, because second derivative is positive there. It's practically the exact same sentence we did on first derivative test. Oh, you know when the sun gets in your eyes, even when you close your eyes and open them, you can still like, so like I can't see. All right, and then we're gonna do the sibling sentence. F of x is what?
Okay.
Concave down where? Negative infinity to -1 because who's your source? Double prime is negative there. Yes.
If there more than one, because it goes to third power. Like, how do you know it's pumping up and down?
Linear.
No, I get what he's asking. So a cubic would do something like this. This would be your inflection point. So you would have concave down. This is the inflection point, and then you would have concave up. There isn't. We just did the math to prove that there isn't.
For a cubic function.
And there actually couldn't be. For a cubic function, there could only be one inflection point. You have concave down and you have concave up, because otherwise it would have to bend again. Like you would have to have to the fourth power and get like another bend in there. Then you'd have another inflection point. Okay. On the back, I'm just going to come down here. I want to show you the one thing that I asked about in that seminar I went to, and they were like, you absolutely cannot shorten that anymore. Let me see, which one was it? Oh, it's the very last one, number 11. What is this the graph of? Well, it's not written very well again. Yeah, F prime. Oftentimes they will give you F prime. Okay, do you all have your sticky note?
Oh, yeah.
I need to write one for myself. Hold on. You're gonna be okay.
My sticky.
Increasing positive, decreasing negative, increasing positive, decreasing negative. Okay, done. Okay. So we are given F prime. Look at where I'm pointing. That's this one right here. You see this? Most of the time, that's the one they give you. Are they going to ask you questions about F prime? No. They're going to ask you questions about F. Okay. So question 11. We want the x coordinates of points of inflection. That would be a change in concavity. Just look where I'm pointing. Change in concavity. That's where the graph we are looking at changes increasing to decreasing or decreasing to increasing. So I asked, can we just say changes direction? And they said no. Okay, so buckle up. This is what they told me the sentence has to be. Where do you see places on here? And linear doesn't count. Okay, so like this one's not going to count. We want changes from increasing to decreasing or decreasing to increasing. I see 4 of them. All right, -4 is one. Good. What else? 2, 4, and 7. Okay, so we're going to say x equals, you got them all. Good job. -4, 2, 4, 7. Because, well, what is the graph you're looking at? First derivative. Because f prime changes from decreasing to increasing or increasing to decreasing there. I asked if that could be shorter and they said no. So I'm just telling you, that's what they told me. So f prime changes from decreasing to increasing or increasing to decreasing there. Cool, and I still gave you a half an hour. Gosh, I'm good. Now, if I'm giving you a half an hour, we should finish this. Yes?